Let's have a go now at finding some inverse functions. So we've got a function f of x equals 2e to the 5x plus 7. So in order to find the inverse function, we essentially need to undo all of the operations here and find out what x would equal to. So to start this off, we're going to say let y equal 2e to the 5x plus 7. And our goal will be to rearrange this and make it x equal to. So first of all, I'm going to subtract 7 from both sides. That will leave me with y minus 7 equals 2e to the 5x. Then I'm going to divide by 2 to get y minus 7 over 2 equals e to the 5x. Next, I'm going to take natural logs of both sides. So I get ln of y minus 7 over 2. And if I take the natural log of e, they will cancel each other out, and that will just leave me with 5x. Dividing through by 5 gives me x equals a fifth log y minus 7 over 2. So my inverse function, f to the minus 1 of x, is whatever we have here, but with the y replaced by x. So 1/5 log x minus 7 over 2. To specify the domain of the inverse function, we need to think carefully about the range of the original function. One way to do that will be to sketch the graph, but it's not strictly necessary if we're aware that the function e to the x is always greater than 0. That means e to the 5x would also be greater than 0, and 2e to the x would also be greater than 0. If we then translate everything up by 7, it means in this function here it is impossible to get a value that is 7 or below. And that means the domain of our inverse function is x is greater than 7, with x being in the real numbers. Okay, at this stage I'd like you to pause the video and have a go at the problem on the right. Welcome back, hope you've had a go. We're going to start by saying let y equal root 2x squared minus 5. And we're going to try and rearrange this to get x equals. I'll start by squaring both sides to get y squared equals 2x squared minus 5. Then I'll add 5 to both sides, so I've got y squared plus 5 equals 2x squared. Next I'll divide by 2, that gives me y squared plus 5 over 2 equals x squared. Then I'll square root both sides to get x equals square root of y squared plus 5 over 2. At this stage I should have a plus or minus in here. However, as seen previously, for an inverse function to exist it has to be 1, 1, which means we can't have two output values here. That means our inverse function, g to the minus 1 of x, equals square root of x squared plus 5 over 2. But we still need to decide, is it the positive square root or the negative square root? To do so, let's consider the range of the inverse function. Recall that must be equal to the domain of the original function. That means we're not allowed to get values out of this function that are negative, because the domain of our original function is positive. So we want the positive version here, and we can ignore the minus sign. To get the domain of this function here, we think about the range of the original function. If we were to put root 2.5 into this function here, we would actually get 0. And this domain was actually chosen so that we never get the square root of a negative number. So the range of the original function would be all of the values greater than or equal to 0. And that means the domain of our inverse function is x is greater than or equal to 0, with x being in the real numbers.